In this episode of the Tech Stack, we're going to be exploring precision timing chips that are the heartbeat of literally every electronic system with a very special guest from SiTime. Next. Welcome back, ladies and gentlemen, brothers and sisters, to another fine episode of the Tech Stack. Here in scenic, sunny New York today with my compatriot Marco Chiappetta from Hot Tech Vision and Analysis, and Rajesh Vashist, Chairman and CEO of SiTime. Welcome to the Tech Stack.
And thank you for having me, guys.
Thanks for joining us.
What a treat.
Yes, absolutely. It's good to see you again. It's been a while.
Yes.
So it's always great to catch up with you on what you folks are doing there at SiTime. But let's start with you, because I'm not sure everybody knows exactly who you are. You'll be world famous someday, probably. But let's first start with a little bit of background on you and the history of SiTime, your company, and how it entered the market.
Yeah, well, I'm pretty much a tech guy, a semiconductor guy. I've been in the Valley since 1984. That really puts it back a long time ago. Been through, depending on how you count it, 5 booms, and 4 busts, or 6 booms and 5 busts. This one is the biggest boom I've ever seen in my life. I've been a CEO of a couple companies, taken a couple companies public. Been a CEO since '99, so more than 26 years. All that means is that I'm free to fail at any point.
Yeah. Well, I mean, hey, I think you got a pretty good track record. But let's explore a little bit of what you do at SiTime and how SiTime came to be.
It's a fantastic story. One day, I'm sure there's a case study in an MBA program coming up, but right now we don't have time for that. It's a company that's been a private VC-funded company, funded by NEA, Greylock, 2 of the top 10 VC firms in the Valley. Then it's been acquired by a Japanese company and lived as a part of a larger company. And now it's been public for the last 6 years. I've had the fortune to be part of all of those. It's been about 19 years. We had a vision all through. That's what unites us. The vision is focus on timing. Timing is big. Timing is important. Timing is underserved. So one of my major theses is that great companies come into large markets that are already established and bring a highly disruptive technology, disruptive market approach to it. And that's what creates the Amazons, the Ubers, or even a Starbucks for that matter. So that's the model that I want to bring. Timing is a large business. It was $5 billion when I started. It's now 10, 11 billion. In a decade, it's probably going to be 20 billion. And it's becoming more and more important with what's happening with electronics. And SiTime is solely focused on just this piece, just timing. But timing is the heartbeat of all electronics. You will hear a phrase P&T, positioning, navigation, and timing. Timing is the boost behind positioning and navigation. And an interesting fun fact today is 1023 day, which is the frequency of GNSS, which is GPS or Baidu, or not Baidu, one of the Chinese ones. So 1023, October 23, that's the frequency. So today is Celebrate GNSS Day. And GNSS is also, of course, powered by very precise timing.
So I think we should educate the audience just a little bit on just how foundational and important clocks and timing are for virtually all electronics. Can you, let's start at the lowest level. Can you explain exactly what SiTime's products do and how they enable the electronics across the world?
Yeah, in a way, I'll start at the highest level. Sure. What we want from electronics going forward is we want autonomy, we want accuracy, we want small size, we want low power. Think of any electronics that you want, whether it's GPUs, CPUs, data centers, automated driving, drones, missiles, a phone, a watch, health. All you want is autonomy. You want it to think. You want it to be smart. You want it to compute. And you want it to be very accurate. You don't want it to goof up, because if you can't rely on that, it's not going to work. You want small size, you want low power. That's it. That's all we do. So what we do is we make it very accurate. We deliver very accurate timing under tough environmental conditions. Think of shock, vibration, temperature, airflow, and accuracy. We deliver that as a combination at all times. What that does is our job is to reduce the errors. The way the errors are checked is through, as you guys know, through bit error rates. BER is talked about. At the low end of the bit error rate, it's 10 to the power -6. That's like a remote for a TV. You don't care much. All the way up to 10 to the power 18. Very accurate. What you really pretty much want is 10 to the power -12, -13, -14. SiTime's technology, SiTime's precision timing, delivers that for CPUs, GPUs, connectivity, GPS, Wi-Fi, everything. That's what we do. Our precision timing makes the accuracy and the autonomy with small size and low power possible. Those are fundamental, I think.
Yep, absolutely, absolutely. So essentially anything that we see a frequency, megahertz, gigahertz, whatever, those clocks are derived from SiTime technology.
Well, those should be derived from SiTime technology if they're doing the job right. But I say we have two kinds of customers, those that are customers today and those that will be customers tomorrow. One of the things that happens in a market which has been around for a long time, 70 years, is that when I arrived in the technology in this business with SiTime, there were clock companies, semiconductor companies, and there were quartz crystal companies. And they were both being consumed by a company, it was a system company that put the two together. But these people seem to have a little bit of a misunderstanding of what they do. They think they do quartz, they think they do chips. What they do is timing. SiTime's genius, if you will, is to put that together and say, timing is important, as I said, and we will only do timing, and we will take non-semiconductor technology, which is quartz crystals, and make it semiconductors, because we're already doing clocks. So clocks plus semiconductors, so we're a complete semiconductor technology. And as you know, whenever you have semiconductor technology, whether it is in transistors, or it's in disk drives, or it's in anything, semiconductors, bulbs, LEDs, they always win. So we think that the future is going to be more semiconductors because of the future value we deliver.
Absolutely.
So literally everything that is electronic has to have a timing product in it.
Absolutely.
Has to have a heartbeat. And quartz crystal was traditionally the way it was done for decades. What makes your product so special, such that you can supplant quartz with a semiconductor solution?
Right. So semiconductors means it's one of the most pure things known to mankind, which means that it's very high quality, very high reliability. It's made in a very pure fab environment, so there's very few impurities. So as a quality, reliability is number one. Number two, we're programmable. So you can program it to do many things, many different frequencies. That's unique. The third is that the precision level that our technology can do is significantly greater. So the performance part comes in. So if you deliver performance, quality, and make it a robust supply chain, I think everybody wins. We know now today, COVID showed us that supply chains are super critical, especially in semiconductors.
Yeah. So MEMS technology, though, let's dive a little bit into that. Geek out a little bit. Because that's what's key to your process.
That's right.
MEMS for virtually everything you make, right?
That's right. So MEMS is just another, you can call it semiconductors or you can call it MEMS. MEMS is a geeky word or a geeky acronym for microelectronic mechanical subsystems. So basically, before I came to SiTime, I was used to circuits, signals flowing through circuits, whether it's analog and digital. But when I came to SiTime, I found that we did another kind of chip, the MEMS chip, which is a vibrating chip, which is a tiny 0.5 by 0.5 millimeter. That's like putting a pencil dot on a piece of paper. Vibrating element that vibrates at the frequency. It can be whatever frequency, 20 megahertz, 50 megahertz, 100 megahertz, for 30 years. Under all circumstances, because it's made of that fantastic material that we talked about. So, yes, it's been a wonderful ride with it. But I do have to say is that although we are using MEMS, a day will come, maybe it's far out in the future, 2, 3, 5, 7, 10 years out, when it's not going to be MEMS, because we're focused on being timing. We're SiTime, Silicon Time. So we're a timing company which uses MEMS technology to differentiate the products that we build. But if it was to move to some kind of quantum technology, we'd do that too.
Quantum timing.
That's right.
Setting the stage for the future. Very nice.
We're going to a new realm now.
Absolutely. Let's
Not quite yet, though.
not yet. We're not there yet. Let's talk a little bit about SiTime's target markets. You know, what type of products you're in now, and what type of products you hope you're in the future.
Well, we have 400 applications.
That's it. Only 400.
Only 400. On the consumer side, we are in smartwatches. We are in health monitoring equipment, things that tell your sleep. We are in AR, VR glasses that are coming, and some of them that are already out.
Oh, wow.
We are in complete virtual reality. We are in smart collars for hunting dogs, so the dogs don't get lost. That's my favorite.
I like that one.
Because I love dogs.
Love dogs, too.
Don't want to lose them. That's in the mobile. Of course, we're in some popular phones. But we're also in military aerospace defense and the serious stuff. We're in drones. We're in missiles. We are in very, very, very important equipment that sometimes gets submerged, sometimes comes up, stuff that flies in the air. We're in satellites. We're in LEO satellites, low Earth orbit satellites. We're in other kinds of satellites. We're in smart fuses. We're in communications equipment. You know, the military spend is going from about 2.5 trillion in a decade to 6.5 trillion.
Wow.
And it's going to change back to the autonomy, back to small size. Think drones everywhere. Think robotics. I mean, what we all saw in Terminator is coming in some way or the other.
Yeah.
It's happening in Ukraine right now, right? And of course, data centers. Data centers, the big spurt of growth everywhere. And SiTime is not any different. So you can think GPU timing, the scale up, scale out piece, whether it's connecting GPUs or connecting them to other data centers or other racks, optical modules, smart cables, baseband, base stations. What did I leave out? Smart cars,
Yeah.
electric vehicles, ADAS, driving, and GPS. We have to keep on coming back to 1023.
Yeah, at 1023. So that...
You know, the reason GPS becomes, sorry to interrupt,
No,
but
please.
GPS becomes important is because with the wars that have happened, including the one started by Russia, the importance is that GPS has become jammed. GPS is a source of atomic time, free atomic time. It's on our watches. It's on our clocks. We get free atomic time. But now, fundamentally, the world cannot trust GPS or GNSS because it's jammable, spoofable, and they need to rely upon precision timing, something that SiTime delivers. And so if you want to locate where your ship is, your plane is, or whatever else, you need GPS supported by time, by localized time rather than received time, because that can't be spoofed or jammed.
So mission critical stuff,
Yeah.
for sure. But let's double click real quick. I'm going to go off a little bit here on a tangent. Let's double click real quick on data center AI and the networking aspect of it, because as we know, networking in the data center is huge. It's not just about how fast you can compute workloads on that single AI, whether it's a GPU or whatever piece of silicon, but communicating across blades, across racks, across a data center. It's huge, right? So what's the opportunity look like for you there?
Well, there are two things that GPUs need. Of course, one, they need to perform the way you just said. But the other thing is they need to have very few errors and they need to be up all the time. one of the things we deliver is getting CPUs, GPUs, any kind of performance is to be up all the time. And that goes to the connectivity. That goes to going from 400 gigabits, as you mentioned, all the way to 1.6 terabits. Right? That's happened in 4 or 5 years, and it's headed towards 3.6. So high throughputs, low latencies, always synchronized, always on. When people are spending hundreds of billions of dollars in these data centers, any time this processing is not happening, it's costing a lot of money.
Yeah, money
Yeah.
and power, absolutely. Are there any significant barriers to entry for, let's go back a little bit now, for designing in SiTime MEMS-based technology, silicon or semiconductor technology, timing technology, versus the traditional Quartz that engineers perhaps decades ago have been designing with so long?
Yeah, so SiTime's been doing this a long time. When we started, we have 5 startups that were competing with us. We had 3 large companies that were competing with us. One was IDT, which got tucked away and sold to
Used to work for
Renesas.
them, actually.
Oh, really?
I did.
Yeah, great company.
Long time ago.
Great company. Silicon Labs, which had a timing division, which they landed up selling, and Maxim, which is now Analog Devices.
Sure, yeah.
So these 3 large companies, SiTime, and 5 other companies. Well, the short story is we prevailed, and for one reason or the other, they all stopped doing it. So SiTime, since 2013, that's what, 12 years,
That's plenty.
has been the sole purveyor, and we have shipped near 3.5 to 4 billion units in this space.
Wow.
But I never rely upon that others are going to fail. I want to build this company, and we have built this company on being so good that as competition comes in, we expect competition to come. How can you have a $11 billion market without new entrants not coming in? They're going to want to come. By performing way ahead of everybody else, by investing, by moving ahead, I expect that that competition in some form will not matter. Either it'll disappear or it'll become a small percentage of the business, which is okay. $11 billion TAM headed to 20 billion. Little competition never hurt anybody. In fact, sometimes I say it'd be great to compete with one of the stellar analog companies so that people can see how good we really are.
That is a perfect segue for the question that I was going to ask. You sort of answered some of it already, but I'd like the audience to understand. Could you explain some of the upside benefits, why SiTime prevailed, like some of the upside benefits of your technology, and if there's any risk to adopting your technology for future customers?
People forget that technology companies win because of people. At the end of the day, technology is one thing, people are a whole different thing. SiTime spends a long time working with people. From the time I came to the company in 2007 to now, we have about 50 people in the company who've been there from 15 years to 20 years. That's a testament to how attractive the culture of the company is. But the idea behind the culture is to create a condition, create an environment where people can go focus on technology. And so what we're focused on, when we started, the MEMS Resonator, the MEMS technology, was something like 2,500 ppm. ppm is a measure of stability. In other words, excuse me, whatever the frequency, how stable is it?
Yeah.
Lower is better, lower number. So from 2,500 ppm, about 5 years ago, 3 years ago, we got to 25 ppm. That's about equal to Quartz. But one day, not so far out in future, we hope to get even lower, maybe in the single-digit ppm. So that's the level of just one technology piece. Behind that, there is jitter, there is phase noise, there is Allen deviation, there's holdover, and of course, the size and power. So SiTime is firing on all cylinders to make our product so compelling that, our customers themselves go, wait, to the adoption of technology piece. Once they start using what we have, they're not used to programmable. They're not used to the quality. They're not used to the reliability. They're not used to a group of almost 500 people focused on one thing and one thing alone, giving them superior timing. That's really that focus, that single-minded focus, which we don't intend to change, on timing is one of our winning points. That's hard to get.
Yeah.
Yeah, and I will say in conversations we've had with you over the years, I'm not a customer, but I love to learn about the technology. And when it's explained in depth, it's one of those things where it just makes sense, right? And when customers hear that, I'm sure they're excited to.
And we have a long way to go. We always need to provide better service, better support, better products. So it's not like we're without faults. I'm sure we have some, but we think we'll be able to overcome them and be the number one supplier, continue to be the number one supplier, particularly in the highly differentiated market. We don't want to be in the commodity market. That's not where the money is. That's not where the fun is.
Yeah.
The fun for our engineers is tough problems.
Yeah. Sure.
Engineers love that. We all love
Absolutely.
that.
Yeah, absolutely. And sub 25 ppm parts per million.
Yes.
That is serious quality.
And that's just the resonator.
Right.
Once we combine it and make it an oscillator, we're already at below a ppb. We're
Parts per
already
billion.
below 0.1 parts per billion,
That's
an
pretty
order of magnitude.
Wow. So again,
Pre-order, sorry.
great straight man here. My next question was about Titan, which is your new family of resonators,
Yes.
MEMS-based resonators. How core is that to timing? And I guess how does that new opportunity take shape for you in the market?
Yeah, that's just driving to the vision. We, the team always had the vision when we first started of getting this down to that number, to that 25 ppm and below that. And we basically think we're going to change the market because now we're going to replace the fundamental technology. And we can do it two ways. One way is the usual way. You supply a resonator, in this case a MEMS resonator, not a crystal resonator. You supply that to somebody making a system, any system like we've talked about, one of the 400 applications. But the one thing we can do with this is it's so small and it's so usable that SoC companies, chip companies, Wi-Fi companies, Bluetooth low energy companies, processor companies, microcontroller companies, they can integrate it on top of their chip, which means there's no more resonator on the board, which is a huge benefit, not just because of savings, but not having to work with non-semiconductor technology anymore. I think it just changes the game. Now, the revenue will take a little while. It won't happen overnight, maybe a year, maybe a year and a half. But as you said, it's a true game changer. Very excited.
That's not achievable with any other type of technology than what you're offering. That integration at the SoC
That's
level.
right. That's exactly right, because it's so small and it's semiconductors. We've been doing it, right? We've shipped already 4 billion oscillators. So we can show our partner, we can show an MCU company, we can show BLE or an LT company, hey, this is how you can integrate it, this is how you can make it work.
I think we should double click on that actually. So let's explain how important and how potentially game changing it is to be able to integrate either on a PCB or right on the substrate for an SoC. What are the benefits for an engineer that's designing a system to move that resonator onto the package?
Yeah, so what happens is typically SoC companies, let's pick on an MCU, microcontroller. An MCU maker, there's about 12 billion, 15 billion of them sold, they're everywhere. They have integrated everything except the quartz crystal. So the quartz crystal sits outside and they set up a reference system, they send it to a maker of, say, a GPS system. And they say, use this quartz crystal. Well, we know what happens. A lot of the contract manufacturers, others, they may cut corners, they may decide to use some other kind. Well, that has a problem with the functioning, and that problem comes to the SoC company, comes to the MCU company. By integrating our resonator, first and foremost, they provide a full solution. Now everything is into it. Second, they don't have to source it. They don't have to get this quartz crystal technology. which also, by the way, needs some other discretes around it. So it's good for supply chain, good for the customer, good for integration, and that's been the history of semiconductors, right? Integration.
Absolutely.
So we're just following it.
Makes sense, like I said.
Yeah, no, higher levels of integration, that's the name of the game, right?
That's right.
So,
With the performance, of course.
sure, yeah, you got to maintain the performance always. What potential market opportunities are you most excited about for your company moving forward? Maybe as it relates to Titan, the Resonator product, or another product you have in the wings. What are the big opportunities for you that you're really excited about?
Well, the Titan technology, since we are on it, is very important because
That's new for you. That's new business. Yeah.
I think it's going to find its way into a lot of non-screen devices. There was that movie where we saw this famous actor moving things around in the air. I think that's coming. There's going to be wristbands that sense motion. There's going to be glasses that project out out without a screen.
Yeah.
And so it's AR, augmented reality, virtual reality, extended reality. So those kinds of things, definitely in healthcare. Healthcare is something very excited about. Continuous glucose monitors, heart rate monitors, blood. So many things are coming our way. Away from the Titan technology, though, clearly data centers are super important, right? I mean,
Sure.
There's an investments of hundreds of billions going on. SiTime has a seat at the front row on this in the GPUs, the CPUs, accelerator cards, the optical modules, the giving timing for retimers, all of that. I think that keeps on going for a long while. And then that AI power needs to be deployed at the edge, the so-called edge AI. That edge AI is probably an even bigger version, robots. I heard the CEO at a conference of Agility Robotics talk about their Digit product, which is a humanoid robot.
Yeah.
And I think that is going to be a big, huge, and it's all the same thing. It's autonomous, it's accurate, because you don't want a 150 robot not moving accurately. Small size, low power, and connected with sensors, connected with radar, LiDAR, and all of that. So really, I think it's an amazing time
It
at
is.
SiTime.
Yeah, it's an amazing time at SiTime, amazing time in the industry. Certainly, physical AI is a big opportunity and a growth market. I mean, I think we're going to be blown away in the next few years.
And so just to add to that, I
Yeah.
heard somebody describe it as a robot, as they say, a humanoid robot, as a LLM come to life.
Yeah. Yeah, that's probably exactly what we're going to
I
see.
really like that.
Yeah, absolutely.
Yeah, incarnate, yeah. But I do like to hear also about the fact of the impact you're making in the life sciences area as well. I think, the technology improving the human condition, health, what have you, is huge. So it's wonderful to know that you're playing significantly there as well.
It's very important. We really take it seriously, and we have the quality, the reliability that must, and the small size that must happen to work in the healthcare business.
Yep.
Excellent.
So let's assume all of your plans come to fruition and the stars align and everything that you're working on, you execute perfectly. Where do you see SiTime in, let's say, 5 years?
My life has always been about aligning stars. It may take a little while.
It does.
But it's great to see dreams come true, and to see SiTime as a significant player already is very heartening. But we've only just begun, like the song, right? We've only really just started. In a few years, I expect that people will understand the value that we bring in timing and the value of timing. And I think the conversation about what is timing, why is it important, will be done and over. And I want to make sure that our customers, our future users, we don't want 100% market share. When I think of the most popular iPhone, it's only 10% units of the market.
Right.
Right? You don't need to to sell everyone on it. You just need to sell the right people on it. And I think we want to give our engineers really tough problems. It keeps them very happy, which is a great thing. We want to keep engineers happy. And keeping engineers happy keeps the investors in SiTime happy. So I think we just keep on playing this song. It's one song. We sing it really well. We'll just keep on singing.
Sounds good.
Well, good luck singing that song, Rajesh, and good luck to your quest for being the heartbeat of literally every electronic system out there.
Well, thank you, guys. It's really good to talk to you, because one of the pleasures we get is when we talk to people who understand the business, understand the technology, and you guys are both technologists. You worked at IDT.
I do.
Great to hear that validation. Thank you, guys.
Absolutely. Thank you for your time. And folks, thank you for joining us, and make sure you hit that like and subscribe button so you get notified when we go live with new exciting content like this. Very interesting stuff. And until next time, we'll catch you on the Tech Stack.